Hello friends. This video is brought to you by mywayteaching.com.
Arithmetic progression. In this chapter, we will study what is an arithmetic progression. Then we shall learn to find the nth term of the arithmetic progression. And finally, we will learn to find the sum of first n terms of the arithmetic progression. In our day-to-day life, we see that many things follow a certain pattern. In this chapter, we shall discuss one of the patterns in which succeeding terms are obtained by adding a fixed number to the preceding terms. Consider the following list of numbers. Each of the numbers in this list is called a term. Also, we can see that each term is one more than the term preceding it. That means second term is 1 plus 1. Third term is 2 plus 1. Fourth term is 3 plus 1. Consider another list of numbers. Here each term is 30 less than the preceding term. That means the second term is 100 minus 30. Similarly, third term is 70 minus 30, and so on. Now consider the following list. All the terms in this list are 3. That is, each term is obtained by adding or subtracting 0 to the term preceding it. In all the examples here, we see that successive terms are obtained by adding a fixed number to the preceding term. Such list of numbers is said to form an arithmetic progression. We shall use the short form AP noun. So now we are in a position to define arithmetic progression. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. The fixed number is called the common difference of arithmetic progression, and remember that this common difference can be positive, negative, or 0. Let us denote the first term of an arithmetic progression by A1. Then the second term will be denoted by A2, and the nth term can be denoted by An. Also, let us denote the common difference between the terms by small d. Then, for the arithmetic progression A1, A2, A3 and so on, we have A2 minus A1 equal to D. Similarly, A3 minus A2 will give us D. For instance, consider the list. Here first term is 6. And the common difference will be 9 minus 6 gives us 3. So that means we can obtain the next term by adding 3 to the preceding term. If we want the next term to the 15, we can write it as 15 plus 3 equal to 18. That would mean that we can write the given arithmetic progression as 6 plus 3 6 plus 2 times 3, 6 plus 3 times 3, and so on. In general, we can say that if a is the first term, then a plus d, a plus 2d, a plus 3d is the list of arithmetic progression where d represents the common difference. We will remember this representation as the general form of arithmetic progression, where a is the first term of arithmetic progression and d is the common difference. Our arithmetic progression can be a finite arithmetic progression or infinite arithmetic progression. For instance, consider the minimum temperatures recorded for a week in month of January for a particular city, arranged in ascending order. Then, this particular arithmetic progression has a equal to minus 3.1, d is equal to 0.1, as each term differs by 0.1, and there are finite number of terms. So this is a finite arithmetic progression. We also notice that a finite arithmetic progression has a last term, while the infinite arithmetic progression will not have a last term. Consider an example of infinite arithmetic progression. Here a is minus 3, d is 1, each term is differing the preceding term by 1, so d is 1, and this list of number doesn't end. So it is an infinite arithmetic progression and it does not have a last term. Now, to know about an arithmetic progression, what is the minimum information that we need? It is enough to know about the common difference? No. We will need to know the first term and the common difference. For example, if we are given the first term a as 6 and the common difference d to be 3, then the arithmetic progression will be a plus d, that is 6 plus 3 is 9, a plus 2d will be a plus 2d will give us the third term, that is 6 plus 2 into 3, that is 12. Fourth term will be a plus 3d, that is 15, and so on. Similarly, if a is given as 6 while d is given to be minus 3, then the arithmetic progression will be 6 plus d, that is 6 minus 3 is 3. Then the next term will be 0. Next one is minus 3, and so on. So that means if we know a and d, we can list the arithmetic progression. So we have seen that if we have a and d, we can list an arithmetic progression. Now the question arises, if we have a given list of numbers, how can we say whether it is in arithmetic progression? Say we have the following list and we have to find out whether it is in arithmetic progression or not. Here, since a is the first term, so a can be found out easily to be 2 in this case. Now we know that in an arithmetic progression, every succeeding term is obtained by adding d to the preceding term. So d can be found out by subtracting any term from its succeeding term, that is, the term which immediately follows. For instance, if we subtract 11 from 14, our D comes out to be 3. Let us check if it comes out to be the same for other successive numbers. Say we take 5 and 8, then 8 minus 5 is 3. Also 5 minus 2 equal to 3. We observe that difference of any two consecutive terms in each case is 3. So the given list is an arithmetic progression whose first term is 2 and the common difference is 3. In general, for an arithmetic progression, common difference D can be calculated by subtracting two consecutive terms AK plus 1 minus AK, where AK plus 1 and AK are K plus 1th and the Kth term respectively. That is, to obtain D in a given arithmetic progression, we need not find all A2 minus A1, A3 minus A2 and so on, that is, all the differences. Instead, it is enough to find any one of them. Consider the list of numbers 1, 1, 2, 3, 5 and so on. By looking at it, we can tell that the difference between any two consecutive terms is not the same. For instance, if we take the first and the second term, the difference is 0. If we take second and the third term, difference is 1. And if we take fourth and the fifth term, difference is 2. So we can say that this is not a arithmetic progression. Consider another list of numbers. Now here A is 6. To find D, we subtract A2 minus A1, that is 3 minus 6, which comes out to be minus 3. Or we can take second and third term, which will give us D equal to minus 3 minus 0, which is also minus 3. So we notice that always to find D, we subtract kth term from k plus 1th term. Let us make the concept more clear through some examples.